Welcome you at the Institut Supérieur de Philosophie, founded by our founder Désiré Mercier, who at the end of the 19th century thought that philosophy without science is completely useless. It's theology. Things changed since then, but still, you can keep that in mind. Also, you are in the Ladrière rooms, which is the founders of the Center of Philosophy of Science here. And if you can watch the page of his dissertation on Gödel, also we try to keep his legacy and his style. What is the style of Ladrière? Except writing in a very obscure way, but that's not the part that we try to keep. The style of Ladrière is that philosophy is an open field. Philosophy, there's no privileged way to do philosophy. Every style is acceptable. Interaction should be constructive. I know now for the young people, I'm just saying things that you don't notice, but I've been trained a long time ago in the United States, and many of us have been trained in the United States, and hyper-aggressive philosophy, or in England, by the way, hyper-aggressive philosophy was the style. You know, you were looking at someone doing a talk, and I was already trying to find a counterexample after 3 minutes of talk. Here, we prefer that you have a robust discussion, but constructive discussion. The goal of discussion is to help the speaker to improve his or her work. I will be also the guardian of the time. So this is the first one, 5 minutes less. Don't get there if possible, and we'll try to keep the time. You have 1 hour, it should be okay for the keynotes. We stream by default to the other members of the research center, but of course, if you don't want it, we will not do it. We record talk by default and put them on YouTube, but if you don't want it, just say it, and we will not do it. But by default, we do it. Okay. What else? Yes, take your badge. Do not forget to sign the attendance sheet that is for our grant agency. And when you have a pause, I invite you to see in the library, there's a very interesting exhibition on the Vienna Circle made by the Vienna University. It's in English and in French. So if you are interested, it's just downstairs in the basement. So, enough talk. We can start. So our first speaker, I have the honor and privilege to invite Alastair Wilson to talk. He will give us a talk. He will give us a talk, if I find the right, a talk on the puzzling non-contingent explanation in science. You have the floor.
How do I? Okay, good morning. Thank you for coming, everybody. Nice to see some familiar faces. So I'm going to be talking about scientific explanation today, and in particular, a kind of category of scientific explanation that I call non-contingent. For a lot of you, you might know these sorts of scientific explanations under the name non-causal explanations, but I kind of am just taking off from their non-contingency rather than their non-causality. And this is a puzzle which I don't think is a kind of, doesn't have, I don't think anybody else has kind of given it this name or talked about it in precisely this way before, but I don't think it's particularly new in the sense that for a long time, I think there has been a puzzle about the status of explanation which isn't causal and which has the features of non-contingency which come along with being non-causal. Which side is best for me to be on? Maybe I'll come to this side so people can still see the screen. So the overall picture is that there is this category of non-contingent scientific explanation which seems to be important, and the role in science that it plays is, I think, increasingly recognized. There are collections on non-causal explanation coming out, and large books. Mark Lang has this large book, Because Without Cause, which deals with many of the kinds of explanations that I'll be talking about today. But we want to understand these explanations completely. That involves understanding the associated metaphysics as well as everything else. And the metaphysics of these explanations, I think, is really unclear. The foundation of it is shaky. So I'm going to try to kind of transmute that unclarity into a sharper kind of puzzle, and then talk about different potential solutions to that puzzle. So I'm going to put the puzzle in the form of a trilemma. You have to choose one of three options if you want to take seriously these scientific explanations. And then I'll talk about some responses you could make to the trilemma, which at least one of them involves rejecting the trilemma. Some of the other responses involve accepting certain horns of the trilemma. And it's not, the upshot is not going to be that you kind of can't be you can't take seriously these non-contingent scientific explanations, but that there are costs associated with each way of taking them seriously. And so we maybe have to choose one of a set of not fully attractive options if we do that. So here's the plan for the talk. I'm just going to give a little background, kind of setting out the kinds of explanations that I have in mind here, and then set up the dilemma. The three kind of the three problematic horns of the trilemma are that making scientific explanation disjunctive, kind of non-unified in its character. They're making these sorts of scientific explanations non-objective, so they don't kind of really kind of tell us about what explains what in reality. And then the impossibility horn requires us to take seriously facts about impossibilities as playing a role in scientific explanation, which intuitively we don't want to do, and I think kind of theoretically has some complications that we would do best to avoid. And I'll explain what each of these is, obviously, in detail. But they all involve kind of metaphysical commitments that one might not want to incur just in order to take these non-contingent scientific explanations seriously and do justice to their role in science. So there are some responses we can make to this trilemma, and these are my terms for them. One is a sort of primitivist response, which I'm calling the grounding realist response. Just kind of take seriously these explanations as explanatory with nothing further to be said about them. They just explain, and that's all there is to be said. There's a view of these sorts of explanations as disguised causal explanations. I think that is an ambitious project, and one which kind of needs to be done. There's a lot of work there open if people want to follow up that response. The idea that there just are no explanations here at all, the sort of deflationary approach that I think goes a little bit against the grain of quite a lot of recent work in philosophy of scientific explanation. And so it kind of involves explaining away the apparent role of these non-contingent explanations. And the last, I think, is interesting and deserves further discussion, though I'm not sure I want to endorse it still, is what I call the causal metaphor response, which says that these, which kind of supplements an explanation response by saying why we find these non-contingent explanations convincing, why they have an explanatory feel to them, even if there is in fact no genuine explanation going on there. So hopefully we'll have plenty of time to go through those sections. So what do I mean by non-contingent explanations? Well, for a start, these explanations are not going to be causal explanations in the ordinary sense. So when one kind of variable changes in the system and that has knock-on effects, causally speaking, and other variables change as a consequence, those sorts of explanations are not targeted by the. So you intervene. You have say a kind of a chemical system at equilibrium, and you add certain amounts of reagent, and the system changes in certain ways, and then reaches a new equilibrium. That's a very familiar kind of causal explanation, and I have no problems with any of those sorts of explanations. Those, I think, are contingent in the sense that those sorts of operations of cause and effect are controlled by causal laws. We take those causal laws usually to be contingent. And there are lots of different accounts of causal explanation available. And they may go in terms of probability, they may go in terms of counterfactuals of various kinds, including, importantly, the sort of interventionist approach, which has been popular recently. That I think of as a kind of counterfactual account. It says, if you were to intervene on the system in a certain way, for example, by adding some more of the reagent, it would change in a certain way, for example, by changing its temperature. And so those are counterfactuals of the kind that are kind of broadly familiar from counterfactuals in everyday life. If I had got lost on the way here, I would have been late for my talk. We kind of know how to assess that sort of counterfactual fairly straightforwardly, and those counterfactuals seem kind of continuous with the kind of counterfactuals that we use in those scientific contexts. If we were to add some extra reagent, then the kind of chemical equilibrium here would change. So causal explanations, not my target, not a problem for today anyway. And maybe there's a kind of sets of cases of scientific facts where there's no explanation to be given. Where for some reason there's something distinctive about the kind of fact that it is not subject to being explained at all. And perhaps initial conditions for the universe have that character. Some people say it's a sort of conceptual mistake to try to explain those. The whole point is that they are not explained by anything. And I think perhaps the most convincing example is the kind of explanations you might seek in genuinely indeterministic theories, like quantum mechanics on a genuinely indeterministic interpretations. So in these sorts of indeterministic cases, you have processes that can turn out many ways. Like the radioactive atom can decay now or it can decay later. There are probabilities. And so if you ask kind of, why is the probability of it decaying now or the probability of it decaying later high or low, then there is answer to those questions. So there's, there can be explanations given of why the probabilities are as they are. But if you ask just the flat question, why did it decay now rather than later, like holding fixed the probabilities, there's no answer to that question. It just is. That's the nature of indeterminism. There is no answer to those sorts of questions. And maybe that was bothersome in the past. It was certainly bothersome to some of the founders of quantum theory. Even now, some people want to kind of give deterministic approaches to quantum theory, partly because they may not like that sort of indeterminism. But that's not a worry for me today. I'm going to accept that we can have, we don't need our explanations to kind of completely span all of the scientific facts. I just want to kind of understand the explanations that we do have. And the category that remains is often called non-causal explanation. It's a scientific explanation, but it's not causal. So what is it like? So there are lots of different proposed categories of non-causal explanation. I'm not going to talk about all of these or indeed many of these in any detail. But I think that these explanations all have something important in common, which is a certain kind of modal character. That there isn't a contingency in the relationship between the thing that does the explaining and the thing that gets explained. And the kind of contingency I have in mind is metaphysical contingency, what kind of really can happen, what really can't happen, if you accept that sort of modality. You could also call it kind of objective modality, though objective obviously has many senses. And at the very least, it's the kind of necessity that is supposed to attach to mathematics. Though the sense in which mathematics could not have been different these explanations seem to have some of that same non-contingent character. That's kind of natural in some of these cases because they are just mathematical styles of explanation. So, topology, branch of mathematics, geometry, branch of mathematics. So it's kind of obvious that some of these, and the explanation that constraint that Lang talks about are also kind of thought of as mathematical in character. So a lot of these explanations just draw on mathematics, and so they're going to inherit all of the necessity associated with the mathematics that they draw on. I'll say a bit more in a minute to kind of motivate their non-contingent character, but hopefully that this will get you warmed up to that. In addition to these kinds of more kind of clearly mathematical cases, there are cases that are more to do with the sort of character of the system. Explanations that are supposed to flow from the structure of the systems involved, or from the state spaces available to the systems involved, or the equilibria that are apt for the kind of systems involved. And it's not obvious here that these aren't mathematical, so it's not so obvious that the character of them is, the modal character is that of mathematics. Here, I think the modal character is more that associated with constitutive facts. So think back to the kinds of facts that were focused on by people like Kripke and other sorts of essentialists when they're talking about the nature of substances, the nature of things. So water is H2O. That sort of kind of claim about what the constitution of a substance is. They're meant to be non-contingent. It's meant to be that water could not have been anything other than H2O. If it had, it would not have been water, it would have been something else. That's the kind of driving thought. And so including these sorts of explanations as non-contingent, as I'm going to be doing, does rely on that general thought that constitution is non-contingent. And the necessity of constitution in Kripke's terms. And so if you reject that, then a lot of these explanations will fall away. There will still be some, I think, which are these more obviously mathematical ones in character, which will remain. And I don't really need all of these explanations to count as non-contingent explanations. I just need some of them to be interesting, genuine scientific explanations that are genuine explanatory and to have that character. So pick your favorite one and think in those terms. And then grounding explanations I haven't mentioned yet. They're also meant, I think, to have this sort of non-contingent character because of the kind of non-contingent character of the kind of constitutive facts about something, the facts about the grounds of a thing. And I will actually be kind of sometimes talking directly in terms of grounds for shorthand. It may be that some of these other explanations are actually better understood as grounding explanations. I think Schaffer does think that. In some moods, I think that. So this is a little bit of a kind of open-ended category that may actually encompass some of the ones above. But if you don't like talk of grounding, if you find that confusing, we can just talk about the above explanations directly. So here are going to be two examples that I'm going to use as the kind of primary examples to lead in. They're the relations between molecular motion and the bulk properties. Think of a gas. Think of a gas that has temperature and pressure. Think of a gas that has temperature and pressure because of the motion of its constituent molecules. And the basic thought here is that where a gas, a real physical sample of gas has a given temperature, it's because the molecules are moving in a certain way, not vice versa. So the molecules aren't moving in a certain way because of the temperature of the gas or because of the pressure of the gas, but the explanation does go the other way around. And I've tried to pose this in a sort of one-to-one sort of explanation. So it's some averaged feature of the of the motion of the molecules. It's perhaps their average linear momentum, perhaps their average kinetic energy. Average kinetic energy and temperature only kind of directly can be equated for an ideal gas. For non-ideal gases, they come apart. But nonetheless, you might think that the explanation is still quite a tight one. It's even if the average kinetic energy doesn't kind of equal the temperature, it nonetheless determines the temperature with a bit of with some correction factors. Likewise, average linear momentum and pressure. But the kind of core thought is that there's a one-way explanation here, from molecular motion to temperature and pressure, not from temperature and pressure to molecular motion. And that directionality can be questioned, and some of the responses we'll come to will question it. But I hope it seems intuitively compelling to you, and that, more importantly, that it does match the kinds of things that scientists say in textbooks and in classes and to one another when they're talking about temperature, pressure, and molecular motion. That this is kind of part of our standard scientific image of the world. If you disagree, then hopefully we can find some other examples that will still be of the same character, but I hope these are relatively commonplace examples. So, first point to make is that they're not causal explanations, or at least not causal explanations in the obvious way. It's not that there's a sort of causal process connecting the momentum or the kinetic energy and the temperature. There isn't that sort of causal gap. There doesn't have to be kind of causal work going on there. The connection here, the explanatory connection, is more direct than that. And it's not contingent in the way that ordinary causal explanations are. That's what I will argue. So I will think of these as synchronic explanations. I don't think that synchronic is essential here, because we can have these sorts of explanations outside of time altogether, perhaps. Perhaps in quantum gravity, we don't want to think of the explanation of time itself by something non-temporal as being synchronic, because it doesn't occur inside time, it kind of occurs outside time. But these cases seem to be synchronic. They're deterministic. It's not that the temperature, the motion of the molecules kind of gives a probability distribution for the temperature, and then it happens to settle on one temperature rather than another. There's no probabilistic element, it's deterministic. This isn't something that we know a priori, just by reflecting on the concepts of temperature and motion. It was hard-won knowledge. We had to do a lot of difficult science, thermodynamics, statistical mechanics, chemistry, and the rest before we were in a position to be confident that these claims are correct. So that's already coming apart from a lot of the kind of classical image of grounding explanations or of mathematical explanations. So they have this character where they appear to have necessity that goes along with them, yet they are a posteriori. And that makes them, I think, particularly interesting. There's something like in the general vicinity of the Kripkean necessary a posteriori, water is H2O, necessary but still required scientific discovery. And for my purpose, the most important character I've already mentioned is that they're directed. The explanation goes in one direction only, or at least it seems to go in one direction only. If in fact it goes in both directions, then we're going to need to explain away why it seems to go only in one. And it's that directed feature that I'm going to be leaning on. So what makes these non-contingent? In the kind of metaphysics terms associated sometimes with the grounding literature, I think it arises from these explanations being internal relations. So necessarily, if the explainer and the explained both obtain, then the relation of explanation holds between them. You can't have a high average kinetic energy of the constituent molecules of gas and the gas being hot without the former explaining the latter. This is a relatively modest form of necessity because it's kind of conditional on the explanans and explanandum holding that the explanation holds between them. But nonetheless, that's a kind of necessity. We can't have the two facts that are related by the explanation without them being related by explanation, and we can't have that as a matter of metaphysical necessity. So this is a standard feature of grounding explanations as people normally envisage them. But it seems to me that this feature is had by all of the forms of non-causal explanation I discussed. So I'd be very interested if you think that there are cases of non-causal explanation from my list earlier that don't fit this model, where it can be that we can have the explanans and the explanandum without them being related by that non-causal explanation. And although there are challenges to the idea that grounding is internal, they don't seem relevant here. I'm thinking of work by people like Alex Sky or Stefan Leuenberger that talk about kind of the possibility of interference of certain kinds. And again, if you think that those sorts of cases are relevant, then we should definitely talk about that. But I'm going to set those sorts of objections to internality of grounding aside. And now we'll move on to the actual puzzle that I've been setting up. So non-causal explanation is puzzling in general. There are many questions that it raises. There are epistemic questions about how we know them, and a particularly interesting one is whether we can kind of deal with their apparent a posteriori character in a divide and conquer sort of way by dividing them into two components and saying one part of them is a priori, one part is a posteriori. Lots of people have tried to do that with non-causal explanations in an attempt to kind of demystify them. But I'm not directly interested in that today. More interesting is going to be the questions about their kind of character, whether or not they are as objective as we take causal explanations to be, or indeed as non-objective. You think that causal explanations have a kind of pragmatic or interest-relative character. And so how do they relate to causal explanations, but also how do they relate to explanations that we talk about in metaphysics, grounding, metaphysical explanation? I'm inclined to think that at least some of them are just cases of grounding explanation, cases of metaphysical explanation. But that's controversial in the scientific explanation literature. And the other kind of question which I'm going to be focused on is how unified they are as a category of explanations. Can we treat different ones of these in different ways? But some of these questions will come up, especially when we're considering the plausibility of the responses I'll talk about. But the main focus is a puzzle that I think is raised by the non-contingency of these explanations. Where does the explanatory directionality that seems to be associated with them come from? What makes it the case that there is directionality here? Why do they run in one direction only? And this is a puzzle because our ordinary answer for causal explanations doesn't seem to be available. So if we give an account of causal explanations in terms of probability raising, that can be an asymmetric relationship. Likewise, counterfactuals. If we give an account of causal explanation in terms of counterfactuals, we'll typically have an asymmetry of counterfactuals. You throw a rock at the window and the window breaks. Well, if I hadn't thrown a rock at the window wouldn't have broken. But if the window hadn't broken, I might still have thrown a rock. It might just have been blocked from reaching the window in some way. So there seems to be an asymmetry of counterfactual associated with that, which gets drawn on in most of the standard counterfactual accounts of explanation. Interventionists have that sort of counterfactual asymmetry. You make a certain kind of intervention, it has a certain kind of consequence, but you suppose that the consequence occurs, it doesn't get you that the intervention would have occurred because there could have been many ways that that consequence could have occurred, not just via the specific intervention you had in mind. So it's a fairly standard view of causal explanation when understood in terms of counterfactuals that we have a counterfactual asymmetry. But there doesn't seem to be a counterfactual asymmetry possible in these non-causal and non-contingent cases. And that's what I think gives rise to this puzzle. Because the temperature in the gas and its average molecular kinetic energy are so closely tied together, there doesn't seem to be a gap there to exploit in terms of a counterfactual asymmetry. Because it seems both that if we were to reduce the temperature of the gas, the average molecular kinetic energy would decrease, and that if we were to reduce the average molecular kinetic energy, the temperature would decrease. There isn't scope for kind of other factors to interfere with those counterfactual connections the way there is in the ordinary causal case. And so where does the directionality come from in these cases? It's an explanation. It's, intuitively, it's a one-way explanation. The explanation goes from molecular motion to temperature and pressure and not vice versa. But we don't have a counterfactual asymmetry to be the source of that directionality. So were we wrong to think that there was directionality in the explanation at all? Or if there is directionality, where does it come from, if not from the counterfactuals in the ordinary way? And one way to recapture that directionality using counterfactuals would be to allow for counterpossibles. So I'm not going to go into this in a lot of detail. I'm afraid I'm going to refer you to a paper I've written about it for the full details. The claim is that there's a certain kind of way of thinking about interventions on these variables which would recapture the asymmetry, but it requires interventions that are not the standard kind of interventions, which I call impossible interventions. How does that play out in this case? I want to say that there is a certain kind of interventions that if we were to intervene kind of directly, holding everything else fixed on the average momentum, that would kind of ramify out to an increase in the temperature and pressure. But if we were to just change the pressure directly in the relevant way, holding everything else fixed, that wouldn't flow out to a change in the average momentum of the molecules. There are certain these are not ordinary counterfactuals now. The interventions involved are a certain kind of grounding intervention. You don't causally adjust the variable, you sort of directly reach in and ground it being different. But the core point is going to be the kind of impossible intervention which would kind of make the pressure higher but leave the average molecular momentum fixed would violate the constitutive principles regarding pressure. This is an impossible thing to do. Why is it impossible? Because it breaks the necessary connection between molecular motion and pressure, which we're taking to be a sort of constitutive fact, thereby non-contingent. And so if we are going to have an asymmetry of counterfactuals to account for this directionality, those counterfactuals are going to have to be counterpossible counterfactuals, that is, counterfactuals with impossible antecedents. Specifically, they're going to have to be counter-metaphysicals, that is, counterfactuals with metaphysically impossible antecedents. So, just to recap, because that went by pretty fast, the kind of initial suggestion is that we capture the asymmetry of explanation in general with a counterfactual asymmetry. And that works fine for causal asymmetry. But if we have these non-causal explanations, any kind of counterfactual asymmetry that could do that would have to, in our evaluation of those counterfactuals, sever the necessary connections between different properties of the system. And so there are metaphysically impossible antecedents. So the sort of counterfactual thinking has to reach beyond the possible worlds into the impossible worlds and look for substantive structure in the impossible worlds. And that is metaphysically fairly heavy duty as a theoretical thing to appeal to. These non-trivial counterfactuals about what would go on if impossible things were to happen. So one of the solutions that I'll consider does go that way. But I just want to kind of put on the table why it's not obvious that we can't just straightforwardly account for the asymmetry, the directionality of those explanations in the way that we might ordinarily do in terms of a counterfactual asymmetry. So with that set up, I hope you feel a bit of the force of this puzzle. Where does the asymmetry come from, if not from counterfactuals in these cases? I want to set up a trilemma that derives from that. So the first horn of the dilemma is making explanation radically disjunctive. So suppose we're happy with a causal account, with a counterfactual account of the directionality of ordinary causal explanations. Maybe counterfactual accounts of the asymmetry are right for causal explanations, but we need a different account of the asymmetry of the directionality for non-causal explanations. The question remains how. And I'm open to ideas. If you have ideas, I'm welcome to hear. I'd be glad to hear them of kind of where the directionality of these non-causal explanations might come from, if not from an asymmetry of counterfactuals. But I think any such account is going to end up making explanation quite significantly disjunctive. If we've got the directionality coming from very different sources, we will end up with very different kinds of thing in the resulting directed relationship. And then it becomes unclear why we have two different kinds of explanation rather than explanation and something else. What makes them both explanatory when the directionality is coming from a different source? This isn't any kind of knockdown objection. This is a challenge to somebody that wants to develop this sort of view. Where does the asymmetry come from, and why does that difference not mean that we've changed the subject away from explanation altogether? And yeah, so a different horn of the dilemma says maybe we don't want explanation to become disjunctive in that way, but we also accept that we can't have like objective directionality from counterfactuals the way we did before. So maybe what we want is to kind of give up on the full objectivity of these explanations and say that the directionality only holds relative to something like a pretense or a fiction or some other way of being non-objective. So perhaps there's a sort of fiction according to which the relevant counterfactuals are true, a fiction according to which we suspend the necessary connection between molecular motion and temperature and pressure, and imagine that we can vary those variables independently. Now we do have, relative to the fiction, a counterfactual asymmetry after all, and it's a counterfactual asymmetry of the ordinary kind, at least in the fiction it is. So now there's no worry about the kind of explanation we have being fundamentally different in character. The problem is instead that character only holds relative to the pretense that we're engaged in. These things can be modally pulled apart. Another way of doing this is to kind of go meta-theoretic or kind of conceptual in the description of the case and say we may not be able to intervene on molecular motion while leaving temperature and pressure unchanged. We may not be able to intervene on temperature and pressure while leaving molecular motion unchanged. But we can adjust those variables in our theories. We can come up with new theories. And we can note that according to some theories, those two things don't always move together as a matter of necessity. And then we can talk about what the theories say rather than about the world in general. So switch our counterfactuals from being about what happens to temperature and pressure if you change molecular motion, what happens to molecular motion if you change temperature and pressure, and instead make the counterfactuals about our theories. What happens to our theory if we change them so that these variables are not linked in the relevant way? And here the problem seems to be a sort of changing the subject. We're not talking about the world directly anymore, we're talking about our theories about the world. So at most, their explanations that we get look like they're going to be explanations about kind of our theories rather than explanations about the world. There's a kind of there's a changing the subject objection here. And I think both of these I'm kind of lumping those sorts of approaches together under the non-objectivity horn, because I think they dilute the intended objectivity of the explanation. We're not now dealing with a worldly explanation where this one feature of the world explains another feature of the world. We're dealing with something that is more to do with our own representations of things. And that, I think, is a big step down from what we thought we were doing in many of these non-causal explanations, at least some of us thought we were doing. The last horn is what I call the impossibility horn, and this is to go back to the idea of counter-possible counterfactuals and to try to take them seriously and say, well, we want to have a counterfactual account of the directionality of these explanations, but we can't have ordinary counterfactuals. We don't want to have ordinary counterfactuals evaluated with respect to a fiction or with respect to our theories, because that would dilute the content that we want for these explanations. So let's take seriously the idea that these counterfactuals concern the world, and take seriously the idea that there needs to be an asymmetry of counterfactuals here, but just let our theory of counterfactuals kind of follow where our needs for it lead, and just make use of counter-possible counterfactuals. So we want it to be that kind of there are non-trivial consequences of impossibility. So that if, per impossibile, we adjust the temperature while leaving the molecular motion unchanged, we can say interesting and substantive things about what would happen from that. And here we need to appeal to some fairly heavy-duty metaphysics. That metaphysics does exist. I mean, there are theories of counter-possible counterfactuals which have been developed by metaphysicians, typically metaphysicians that are interested in understanding inquiry in mathematics or in metaphysics or some other non-contingent domain. And the thought might be that when we're dealing with non-causal explanation in science, we may be dealing with non-contingent domains. So this is just kind of another application of this machinery in a place where it was kind of suited to be applied. And if you are an enthusiast about counter-possible counterfactuals and maybe impossible world semantics for them, such that there are kind of non-trivial facts about what hold at certain impossible worlds, and there are facts about which impossible worlds are closer than other impossible worlds, and so on, then we can go that way. But metaphysically speaking, this is a pretty heavy-duty approach, and even in kind of speculative metaphysics, counter-possible counterfactuals and impossible worlds are pretty controversial. And generally speaking, speculative metaphysics is less well liked by philosophers of science than it is by the metaphysicians which produced it. So it would be a somewhat I think kind of controversial move within philosophy of science to lean on this metaphysical work here to solve this puzzle. Perhaps it's the best way to go. Perhaps the answer is that philosophy of science should, after all, be taking seriously the sorts of counter-possible metaphysics. But I think that is an outcome that a lot of people are going to find unsatisfactory. So those are the three responses, those are the three horns of the trilemma kind of characterized in a way which kind of responds directly to the puzzle. I've tried to kind of group together the three ways of responding to the puzzle in a way, the way which kind of gives the most, kind of classifies them most neatly, puts them most in common, but that doesn't line up necessarily with the ways which are going to be kind of actually well motivated for actual philosophers, given all the other commitments which actual philosophers hold. So I think there's certain packages of views which are going to be the source of kind of coherent, well-motivated responses, and I'm going to try and talk about those separately. So these kind of sort of line up with the horns of the trilemma, but not neatly. So the first approach is to think of all of these explanations as causal explanations in disguise. So this is revisionary to the extent that recent philosophy of science has taken seriously that these non-causal explanations are non-causal and can't be reduced to causal explanations. But it's not unprecedented. There are causalists out there that have kind of systematically tried to account for various of the non-causal explanations in causal terms. So Strevens has, in his book Depth, has an influential account of equilibrium explanations as highly abstract causal explanations. They're just causal explanations, but kind of a sort of extreme kind, an extremely abstract kind. Likewise, Lina Janssen and my colleague Juha Saatsi have argued that topological explanations have this character. They're causal explanations that are like extremely abstracted. We're kind of used to more or less abstract causal explanations where we deal with more or less general features of the system being studied. This is where we kind of turn the abstractness up to 11 and go for the most abstract possible sorts of causal explanations. They look kind of like topological explanations. At least that's what Janssen and Saatsi claim. And I'm actually fairly sympathetic to these particular approaches. What I don't think is that they're going to be able to apply across all of the spectrum of non-causal explanations I was describing, in particular not to the leading examples I was using of temperature and pressure. And so that's going to be kind of the problem with this response. Like it's more of a challenge than a knockdown objection. It's like, if you want to go that way, there's a lot of work that needs doing. You need to do that kind of hard work of showing for each of the candidate non-contingent explanations how for them as causal explanations after all. And equilibrium explanations, maybe it looks kind of good. Grounding explanations looks rather harder. And perhaps then the correct response is sort of divide and conquer approach. Say, we'll look at all of our non-causal explanations, we'll kind of work out which of them can and can't be understood as causal explanations in disguise. And we will take seriously as explanatory all of the ones that, that can be accounted for that way. But where that strategy fails, where there's no plausible way of seeing the explanations as causal explanations in disguise, we use a different strategy. Perhaps the next response on the table, which I call the primitive grounding response, which says that, well, actually, I've rearranged the order of these. This was going, the natural thing to account for those with it will be the one that comes next. So pause that thought for a moment and instead think about a sort of primitivist response that says that maybe what this is evidence that we need to have some sort of primitive explanatoriness in the world, some sort of relation which is explanatory in reality, but where there is nothing more that can be said about why it's explanatory. It just is explanatory, and there's no informative account of how that explanation functions, of how that explanation works. So that maybe there is an explanation in counterfactual terms of how causal explanation works. When it comes to grounding, there just is no explanation, or maybe even causal explanation is not to be accounted for in counterfactual terms either. Maybe it's all maybe all of these explanations are primitive in character. And the most plausible way, I think, to get yourself into the mindset of this is to think that somewhere in reality there needs to be some directionality. There's a lot of facts out there in the world. There are objective explanatory relations between them. And that's got to be accounted for somehow. If it's accounted for in terms of counterfactuals, then that just kind of pushes the question back, kind of, where does the asymmetry of counterfactuals, what can that be explained in? And when we go about starting to explain the asymmetry of counterfactuals, maybe in terms of some other asymmetry, we ask kind of, what can that be explained in terms of? And you might think that there's a sort of regress that looms that at some point needs to be blocked by just saying, well, this just explains that and that's all there is to it. We can't account for that explanatory directionality in any other terms. So suppose you were kind of motivated by that sort of regress sort of worry into thinking, well, somewhere there's got to be primitive directionality in the world with no further explanation to it. Why not here? Why not just put that straight in our cases of interest, into our cases molecular motion and temperature? We have this relation, call it grounding, which is just the name for the relation of kind of primitive explanatory directed dependence, and we can use it whenever we think it's needed, including in the case I've been talking about. You might even then try to say, well, we need some metaphysical primitives. This is a really good one to use, and we can use this instead of some of the other ones we already had on the table. So it's like perhaps a parsimonious choice of metaphysical primitives. All this is the kind of thing that you might find fundamental metaphysicians saying. It's kind of alien, I think, to the scientific explanation literature to appeal to those sorts of thoughts. It's at least quite speculative relative to that literature. So I think this is going to be unattractive to philosophers of science working on these explanations, even if some metaphysicians might find it more appealing. And a big part of the problem is epistemic. If this directionality is just primitive, how do we detect it? How do we know about it? Because we do seem to know about the the directionality of the heat and molecular motion kinds of cases. How do we know that? If it's just primitive, it looks like there's no way we could know it, because there's no way we could know any facts in virtue of which it obtains, because it doesn't obtain in virtue of any facts. The directionality is just there. So, that's bad enough if if that is the case for non-causal explanations. It makes them epistemically inaccessible. If we wanted to give a unified account of causal and non-causal explanations along these lines, then we'd get causal explanation also inheriting that epistemic difficulty. So I think this is kind of piling obscurity onto obscurity, really. And so the more empiricist your tendencies, the less appealing you're going to find this approach. This is really one for the rationalist metaphysicians amongst us. So this is the sort of response now, the no explanation response that you might go with if you attempted to do that divide and conquer thing. Say, well, some of these explanations are disguised causal explanations, and the ones that aren't really explanatory at all. They just kind of look explanatory, but that's an illusion. So here, the response, I think, is best panned out by is best filled out by saying we don't have explanation here at all. We just have theoretical identity. So pressure just is average linear momentum, temperature just is average kinetic energy, or maybe is like them with some sorts of correction factors. But either way, we have an identity claim here. These are two different properties. This is one and the same property under two different descriptions, under two different names. And if we have one and the same property under two different names, then there's no real explanation there, any more than there's a real explanation of why Superman is Clark Kent. There isn't any explanation there, there just is an identity. So in this case, there's no explanation here, but it looks like there is. Obvious question, why does it look like there's an explanation here? And one suggestion that I think is an interesting one is to say that we mix up these cases with a sort of multiple realization case. Because what I've been talking about is kind of cases of one-to-one explanation, where having a certain pressure is having a certain kind of average collective property. And that seems to stand in a one-to-one relation. There are also similar relations in the vicinity which are many-to-one. So we might think that, like, for one given pressure state, there are many different very specific microstates that realize that pressure. And here we do have counterfactual asymmetry available, because we can say something like, well, if it wasn't in this microstate, it would be in another nearby one instead, in which case it would still have the same pressure and the same temperature. But if it had a different temperature, it wouldn't be in any of those microstates. It would have to be in a microstate which was so different that it would be very different. So we can recover a counterfactual asymmetry here by moving to sorts of cases of many-one determination. But those are different cases. Perhaps it's quite correct that there is a causal account of the asymmetry, counterfactual account of the asymmetry there. But that won't extend to all our examples. And so this would be a solution to our problem. It would be an account of why we think there's an explanatory directionality in these cases when really there isn't. So why don't I like that response? Well, again, it's a sort of promissory note. It's not obvious that it's going to work in all the relevant cases. Maybe it works in some of these cases of sort of constitutive explanation. It's not obvious it works so well in the more mathematical explanation types of cases. But the examples seem explanatory. There's a kind of intuitive cost here. Perhaps we're used to intuitive costs. I think there's equally a high methodological cost. We'd have to kind of take claims of explanatoriness in scientific textbooks and kind of filter them, work out which ones are just seeming explanations but not real explanations, and which ones are really explanations. So it's going to kind of force us to kind of read selectively the outputs of science and science education when it comes to reading off the objective explanatory structure of the world from them. Maybe that's okay. Maybe that's just something we're going to have to get used to doing. But I think these are prima facie costs of this approach, and it would be better if we could have one to have an approach which didn't require kind of explaining away as an illusion the explanatoriness of these cases. Perhaps that those worries about the intuitive methodological costs of this can be helped a bit by saying the sort of saying the following, saying that in these sorts of cases of non-contingent explanation that aren't really explanations but just look like it, they look like it because of a certain psychological phenomenon that's going on in us. That's the phenomenon of sort of projecting causality where it doesn't belong. So on this view, there is no non-causal explanation, but it can be useful for us to think and talk as though there is. And that's why there's lots of this sort of talk in our ordinary discussions, in kind of introductory metaphysics and philosophy of science classes, and indeed in science textbooks. And the metaphor is a causal one. We imagine that these cases are causal when in fact they're not. And the reason we do that, says this hypothesis, is that we're good at causal thinking. We're perhaps evolved to successfully perform causal reasoning. Or perhaps we have some sort of causal reasoning modules in our brain. Or perhaps it's kind of super socially deeply ingrained to reason this way. Or perhaps it's built into our linguistic framework, something like that. Like lots of etiological hypotheses for why causal thinking is so deeply rooted in our practices. But never mind why it is. If it is, then it's not surprising, perhaps, that we're going to attempt to think causally about these cases, even when they're not really causal in character. Maybe because we kind of can't help but doing it, or maybe because we get desperate and want to, think about them some way, and this is just the only way available to us. And on this view, non-causal explanation is a sort of metaphorical repurposing of causal explanation. And I think an interesting paper that hasn't got as much attention as it could have done, by John Shaheen, argues for this view. And it kind of draws on evidence from linguistics and says cases of metaphysical explanation have the kind of markers that linguists use when they are looking for cases of metaphorical talk. There are sort of tests for metaphoricality.